Today's lab will focus on another day of optimization, so you can title this Optimization 2. So take a moment to copy the question down in your notebook, and then when you're ready, press play. A square sheet of cardboard 12 inches by 12 inches will be made into a box by cutting equal sized squares from each corner and folding up the four edges. What will be the dimensions of the box with the largest volume? So, largest is the keyword we want to underline. Largest means we're going to find a max. And what are we going to maximize? The volume. So I went ahead and drew out two pictures. We're taking this piece of 12 by 12 cardboard. So I'm going to label each side 12 by 12. Obviously it's a square. And we're cutting out four corners. So we're cutting out this corner, this corner, this corner, and this corner. And the question is, what will the dimensions be that will produce the largest box? So we'll fold it up and we'll create this box here. So I don't know how much I'm taking off each side. That is the question. So I'm taking off, I'm going to call X basically at each corner. They said we're taking out squares, so I know it's going to be X by X. So now I have to consider if I were to take this off, what will the length of my new side be? Well, remember, this whole length was 12, and I just cut out 2 x's. So I'm going to say that's 12 minus 2x. Same idea on this side. This whole length was 12, and I'm cutting out this corner and this corner. So I'm going to say this new length here is going to be 12 minus 2x. So let me just wrap this one up. This is really the 12 minus 2x, not the entire piece. So my volume formula for a rectangular prism is length times width times height. So my length is 12 minus 2x. My width is 12 minus 2x. And now I need the height. So look at this. This piece here is what we folded up. Okay, to create this box, we basically just folded those two up, glued them together, and it made that seam there. So how tall is that piece? Well, it's as tall as the part that I folded up. So I would say this has a height of x. So my height is going to be x. Now, what's unique about this problem is that it's already in terms of one variable. We just have to clean it up, take its derivative, and prove that we have a min or a max. So again, I wouldn't take the derivative here right off the bat. I would probably do a little bit of cleanup, and that's what I'm going to do. I'm going to FOIL these two out. So that's 144 minus 24x minus 24x minus 48x plus 4x squared. And it's all of that times x. So again, I'm still creating a max. 144x minus 48x squared plus 4x cubed. So I've got my function in terms of one variable. I'm going to take its derivative and set it equal to 0. I'm going to go ahead and factor, so I'm just going to rewrite these for myself. 12x squared minus 96x plus 144. Looks like I can pull out a 12. So that's left with x squared minus 8x plus 12. Let's see, 6, leave my 12 out in front. 6 times 2. Looks like that factors, setting that derivative equal to 0. I get x equals 6 and x equals 2. Now that doesn't mean both of those work or both of those are maxes. So we need to go back and remind ourselves that we want to maximize this function. So I'm going to say I don't need any negative numbers since I'm creating an object here. I'm going to use 2 and I'm going to use 6. And I'm going to plug those into v prime. And I'm going to use that factored version. Remember, that's always the most useful one. So my factored version is right here with that 12 in front. If I plug in a 1, 12 is positive, 1 minus 6 is negative, 1 minus 2 is negative. That creates a positive. If I plug in a 3, I get positive 12. 3 minus 6 is a negative. 3 minus 2 is a positive. If I plug in a 7, again starting with a 12 is positive. 7 minus 6 is positive. 7 minus 2 is positive. So you'll notice that 6 creates a min and 2 creates a max. And remember, my goal was to maximize the volume. So let me just go back and review what the question is. What will be the dimensions of the box? All right, so I know when x equals 2, I have a max. We said the length is 12 minus 2x. The width is 12 minus 2x, and the height was just x. So that tells me this is going to be 12 minus 4, 12 minus 4, and 2. So I've got an 8 by 8 by 2 box that would produce a box with maximum volume. Question 2, same idea, copy it down. This one's slightly different. A box with a square base and open top must have a volume of 42,592 centimeters cubed. Find the dimensions of the box that will minimize the amount of material used. Okay, so clearly my calculus term is minimize, and I want to minimize the amount of material used. That is known as the surface area. And the other key they gave me was volume. So I know I have two equations, one in terms of volume and one in terms of surface area. Now again, this is leading towards drawing out yourself a picture, and notice that they said the base is square. So I'm going to start with a square, okay, and just remind myself that all those are equal sides, and kind of draw in my three-dimensional piece there. Okay, so my purple base, excuse me, is my square. And I know that the volume, let's make a note there, is 42592. Okay, so since this is a square, I'm going to go ahead and label the base x by x. And again, that's my purple piece, that x by x. Now, it's not a cube. That means the height is going to be something different. So I'm going to go ahead and label this height with a y. Okay, so again, the only reason I called this base x by x is because it's a square. If it didn't say square, this would be x by y by z or something. All right, so I know volume, again, is length times width times height. So volume equals length times width times height. So I know my volume is 42592. My length is x, my width is x, and my height is y. So remember, in order to minimize or maximize a function, we need a function in terms of one variable. Now this doesn't have the word min or max, so clearly I have another function. I want to minimize the surface area. Now surface area, I think is pretty obvious. It's like it sounds, it's the area of every surface. So this is a cube, obviously, or a rectangular prism. So it has 6 sides. The only catch is that it said it had an open top. So we really only have 5 sides. Basically, this top is not closed. Picture a box that's open, we have an open top. So all we need to do is state the area of every surface. So I'm going to start with the bottom square. This area of this square is x by x. So I know I have x squared. Plus, now I need the area of every side. So I'm going to go ahead and kind of shade in one side and just say, what are the dimensions of this side? So if I look at that, that is an x by a y. Okay, so now I have to ask myself, well, how many x by y sides do you have? Well, of course, this side is the same as the side across from it, so I know I have 2 of them. Now let me talk about this side. Grab a different color here. This side is also x by its height, which is y. So in fact, I have 4 x by y sides. So again, the base was x by x, that was the bottom, so x squared, and I have 4 congruent sides, so 4xy. So my goal is to write this equation in terms of one variable, take its derivative, set it equal to 0. So again, you can solve this equation for x or for y, but I notice there's only one y, so I'm going to solve this for y because I only have to substitute it in once then. So I've got 42592 divided by x squared equals y. And I'm going to substitute that in there. So my min equals x squared plus 4x times 42592 over x squared. And again, I'm going to clean it up first. That'll make my life a lot easier. And I'm going to cheat on my calculator. 42592 times 4 gets me 170,368. Now this x and this x produce an x in the denominator, but I'm going to bring it up to the numerator and call it x to the negative first. Now we're ready to derive just like we did last week. So 0 equals 2x minus 170,368, x to the negative 2. When I go to rewrite this, remember this x to the negative 2 is only on this one term. And then I want to get myself common denominator. So I'm just going to multiply this piece by x squared over x squared. Okay, so I've got 2x cubed minus 17,368 all over x squared. When I have any fraction equaling 0, remember you want to set both the numerator and denominator equal to 0. So here I just get x equals 0. Again, I'm going to cheat with my calculator here. Divide that by 2 gets me 85184. And I'll take the cubed root of that. And I get x equals, so cubed root each side, 44. Now again, make sure you answer the question. Clearly I'm going to reject 0 because I wouldn't have a side if I left 0. I do want to quickly show that 44 is either a max or a min. So I'll test 1. 1 cubed times 2 is 2 minus this huge number over 2 squared is obviously a negative number. If I test 50, 50 cubed times 2 is bigger than that, so I know I've created a min at 44. Now remember, we just need to make sure we answer the question. We know we have a min when x is 44, and the question says find the dimensions. So if I go back to my picture, x equals 44. So this base is also 44. And then I just need to go get my y value, and you should have an equation that says y equals. So I'm just going to take that number, 42592, and divide that by 44 squared, and I get a y value of 22. So my dimensions are 44 by 44 by 22. All right, last question, and abbreviate what you need to. You're building a glass fish tank that will hold 72 cubic feet of water. So again, pause it, write it down, and then play it back with me. So I'm sure you can picture a glass fish tank. You want its base and sides to be rectangular, so that's key, and the top to be open. You want to construct the tank so that its width is 5 feet, but the length and depth are variable. Building material costs $10 per square foot for the base, $5 per square foot for the sides. What dimensions are the least expensive tank, and what is the cost of the least expensive tank? So again, this leads to drawing yourself a nice picture. So let me get my fish tank down. Now the only thing they said you had to have is that the width, okay, is going to be 5 feet. That is non-negotiable. It is a 5-foot width. And the height and length will be variables. So I'm just going to call this L and W, L and H for length and height. All right, so let me start with my volume formula. Volume is length times width times height. So I'm going to say my volume equals L times H times 5. That's the only thing I had to put in there was that width of 5. And I know that the volume is going to be 72. So I'm going to say 72 equals length times height times 5, so 5 LH. So there's my first equation. Now I need to minimize or maximize something. It says least expensive, so I know I'm going to write a min equation. And what am I going to minimize? Well, if it says expensive, then basically my goal is to minimize the cost. Now, how do you go about doing that? Well, they were charging a certain amount for each side. So we need to think about our surface area. So again, I'm going to shade in the bottom piece and just ask you, what are the dimensions of this bottom piece? It has a length times 5. So I'm going to say my length times 5, and I'm going to ask you how many of them are there? Well, in theory, there's 2. There's the bottom piece and the upper piece, but it's an open box top, so we're only going to say that there's one of them. And then we're going to add on The next dimension, let's say it's this side. So what are the dimensions of this side? 5 by h. And how many of those do you have? Well, the opposite sides, of course, are congruent. So I'm going to say I have 2 of those. Then you'll notice I have this front side. I'm going to shade in my front side here, basically. And say, okay, well, what are the dimensions of that? Well, that is L by height. So L by height, and I have opposite sides are congruent. I have 2 of those. Now, we haven't minimized the cost yet. All we did was write our formula for surface area. Now we have to think about how much each side cost. So if I go back, it says $10 for the base and $5 for each side. So if you remember, my base was my red one, my L by 5, and they're going to charge me $10 for that side. So I'm going to say 10 times L times 5 plus, this is a base here, the blue side was a side, and they're charging $5. So 5 times 5 times h times 2. And again, this was also a side, so 5 times L times h times 2. All right, so I'm just going to clean that up. So I'm going to say that's my minimum equals, that's 50 length, plus 5 times 5 is 25, times 2 is 50h, plus that's 10 length times height. Okay, now I need this whole function in terms of one variable. So I can either solve for L or for H. And if I look, there's 2 L's and 2 H's, so it really doesn't matter which one I solve for. Just so we're on the same page, let's just say we solve for H. So H is 72 divided by 5L. So I'm going to substitute that into every H in my equation. So I have my minimum equals 50L plus 50 times 72 over 5L plus 10 times L times 72 over 5L. Now, I do a lot of cleanup because that makes my math easier in the end. I wouldn't typically multiply these terms first. I'd say 5 goes into 50 10 times, so that's going to get me 720 over L, and I know I'm going to derive it, so I'm going to bring that as L to the negative 1. 5 goes into 10 twice, so that's going to get me, oops, I think that L was in the denominator, I apologize, those cancel. That's going to get me a 144. Okay, so now I have my minimum function in terms of one variable. Simply going to take its derivative, set it equal to 0. So that's 50 minus 720 over L squared. And then the derivative of 144 obviously cancels. I'll get that common denominator, so multiplying by L squared. So you should have 50L squared minus 720 all over L squared. I'm going to set both that top and bottom equal to 0. So 50L squared minus 720 equals 0. L squared equals 0. So I get L equals 0. Here I get this L equals the square root of 720 over 50. Now that's not looking like a nice number, but that's okay. Again, I'm going to steal my calculator. 720 divided by 50. And I get L equals 3.795. Remember, AP Calc is 3 decimal places. So now that I have L, I just need to prove that it's a max or a min. Obviously, I don't want negative, so I don't need to worry about comparing 0. So I have 3.795. I'm going to test 1 and I'm going to test 4, and I'm just plugging them back into my derivative. So if I test 1, that's 50 minus 720 is negative over a positive. That's clearly a negative. If I test 4, 4 squared is 16 times 50, which is greater than 720 over a positive. So I know I created a min when x equals 3.795. Now, remember, there were several questions here. It first wanted to know what are the dimensions. So I know, sorry, I shouldn't say x. I guess that was the variable I got for L. My length is 3.795. And if I go back, I should have a formula for width, or height. My height is equal to 72 divided by 5 times 3.795. So I can say, plug and chug that in my calculator. I actually get 3.795, which means that that side was a square. And obviously my base there was 5. So my dimensions are 3.795 by 3.795 by 5. The other question it wanted was the least expensive. So now I need to plug those numbers back into my cost equation. And if I look, my most cleaned up cost equation, I guess is right here. So I'm just going to carefully plug in my length, my 3.795, into this equation. And again, I'm just going to plug and chug in my calculator. And you're welcome to do so on any part of the sheet that needs it today. And I get 523.473. Well, like I said, we tried to do 3 quick problems today. And good luck on your practice.